All right, number 11. This question asks you to circle the two ions with the same number of electrons. Okay, so here's the thing about electrons. If we are talking about atoms, the atomic number is the same as the number of electrons. And that's because in an atom, atoms are electrically neutral, meaning that the positive protons are equal to the negative electrons, right? And so that's why they're neutral. But an ion, remember, ions have either gained or lost. So, and that has to do with these little positive and negative numbers that you see as superscripts on the elemental symbol. So remember, hopefully you know this, but those oxidation numbers, positive means that we have lost electrons, and negative means that we have gained electrons. Okay, and so basically the oxidation symbol tells us if we're losing or gaining electrons, and then the actual number tells us how many electrons have been gained or lost. So sodium has lost 1 electron. So you just want to think about how did sodium look as an atom. So here's sodium. Sodium's got an atomic number of 11. And that means that as an atom, it's got 11 protons. It also has 11 electrons. It's got an oxidation state of +1, which means that it has lost 1, which means 11 is now 10. Okay? We got to do that for all of these. Okay, bromine, we've got a negative oxidation state. Bromine as an atom is right there at 35. So 35 electrons, gaining 1 more gives us 36. Fluorine. Fluorine as an atom has 9 protons and 9 electrons. Also a -1, which means that we're gaining 1 to be 10. Ooh, sodium has 1, or sodium has 10, and fluorine has 10. There we go. Phosphorus. Phosphorus is a -3. So phosphorus goes from having 15, there's its atomic number 15, that's 15 protons, 15 electrons. -3 means we've gained 3, that's 18. And finally, nitrogen, -3. So we go from nitrogen here with an atomic number 7, 7 electrons, get 3 more, that is 10. Hey, in this question, we've actually got 3. Circle the 3 ions with the same number of electrons. So sodium, fluorine, and nitrogen all have the same number of electrons as ions. Okay? All right. Number 12. Number 12. Of the following elements, which is the only one that can form multiple ions? So that has to do with this page in your chemistry Bible. So if you remember that these elements here that live in these taller columns, we call these the representative elements here, the representative columns, they really only ionize in one particular way. That's why we can put these positive numbers above some of the columns and then the negative columns above some of the other columns. And we know we can predict with a lot of certainty how elements in those columns are going to ionize, meaning what is their oxidation state going to be? Well, in this column, those elements are going to gain 3 electrons. That's all they can do. That's the only way that they can behave. And so the elements that live in these columns, they only have one behavior. They only ionize in one way, by either gaining an electron, losing electrons if you're red, or gaining electrons here in the blue columns. This middle ground here, the transition metals, the D block, they are the ones with multiple personalities. That's why we have a question mark above them, because we don't know. What we do know is that they really only form positive cations, meaning that they're only really losing electrons to ionize, but they have multiple oxidation states. So we're looking for, in this list here, we're looking for an element that comes from the D block, and it's copper. Lithium is always +1, oxygen is always -2, and calcium's always +2. But copper comes in a couple of varieties, +1, +2. I'm not sure if there's a +3 or not, but anyway, there's multiple oxidation states for copper. Like there is for many, if almost all of the D block metals have multiple oxidation states. Okay. All right. Number 13. Which of the following has only ionic bonds? Okay. This is a good one because we actually have 3 compounds that we would consider to be ionic compounds. I would say that sodium chloride, ammonium fluoride, and calcium phosphate are all ionic compounds because we're bonding metals to nonmetals. Now, the deal here, though, is that the answer to this question, I would say, is sodium chloride. And the reason for that is that here in this, and this, remember, is ammonium, which is NH4. And believe it or not, that's bonding nitrogen atoms to hydrogen atoms. And typically ionic bonds are formed when metals form to nonmetals, or bond to nonmetals. And here we've got 2 nonmetals bonding up together. So even though that ammonium fluoride is a ionic compound in general, the ion of ammonium is really made with covalent bonds, and then that structure is then ionically bonded to fluoride. So that's exactly like how it is for calcium phosphate as well. PO4, looks a little something like this, where we've got these covalent bonds between nonmetal oxygen and nonmetal phosphorus, and so those are covalent bonds. And this question is saying, well, which of the following has only ionic bonds in it? Sodium bonded to chlorine, that's the only one. Water, that's all nonmetals, so no brainer. Okay, number 14. Which compound contains a polyatomic ion with a -3 oxidation state? So this, which I think is probably the most important page in your chemistry Bible. You have some variety of this for sure. These are your polyatomic ions that we use most frequently. And here's the -3 anions. These are the ones that we use typically that have a -3 oxidation state. And so let's just look in our list of options here for the compound that contains a polyatomic ion with a -3. So let's go through these. Hydrogen is not a polyatomic ion. Carbonate is, it's a -2. That's that one there. Sulfate is also a -2. Phosphate, that's our -3. So that's our answer. And we can find that here. See it right. Where is that one? Oh, right there. Yeah, phosphate. And then the other ones we can find. Carbonate is in here in the -2s, and so is sulfate. And then this one's actually kind of interesting. Ammonium, this is a +1 cation, and nitrate is a -1. So anyway, this the only one that with a -3 number is calcium phosphate. Okay. Excuse me. And finally, number 15. What is the chemical formula that forms when calcium and sulfur combine? So this goes back to the beginning, and we're lucky enough to be working with 2 elements that come from oxidation, certain columns on the periodic table. So calcium, always +2. If it's going to bond to a nonmetal, it's going to give away 2 electrons. Sulfur, on the other hand, is in the -2 column. That means that it's going to accept 2 electrons. And that sort of makes a stable octet for both atoms, and that seals them together with an ionic bond. So here we would just say calcium with its oxidation state of +2 sulfur with a -2 oxidation state. Remember that when these numbers are the same, then we can just smash those two symbols together, and we don't have to do any subscripting or anything like that. If the +2 and the -2 cancel each other out, like they do here, then we just push those symbols together and call it a formula. Okay?